how you doing? I'm Mark Senerth with the Walt Disney Company, and I'm here today to talk about a hub-and-spoke approach for scaling storage. First, I'd like to tell you a little bit about myself. I've been with Walt Disney for approximately 15 years, working on a variety of different problems and different data sets over the years. I'm big on architecture and big data and real-time, low-latency systems. In my spare time, I like to play golf, tennis, spend a lot of time with my family, going hiking and playing with my 3-year-old daughter. And recently, we started to raise chickens. A lot of people tell you stories about a COVID-19 puppy, but not with us. We're starting to raise chickens, COVID chickens. I'm going to introduce you to my colleague, Mohan, and he's going to tell you a little bit more about himself.
Thank you, Mark. Hi, I'm Mohan. I'm with Walt Disney for more than 4 years, and I'm managing the core platform team here, and we are implementing a lot of cool technology. And in my free time, I would love to spend time with my family. I love to watch a lot of movies, and I'm an avid fan of cricket.
Thanks for that, Mohan. To start you off, I'd like to lead with a quote from the great Steve Jobs. He once said, "Creativity is just connecting things." It's up to us as a platform to enable that creativity by making it easier to make those connections in a secure and governed way. What does the ideal data platform look like? Ideally, we'd like to be able to move fast and onboard data into our data lake as quickly as possible so people can make those connections as close to real time as possible. Sharing data should be easy in the platform, both intra-company and inter-company. We should try to enable the business in an easy to maintain way. So that way, there's not much overhead and things are centralized and easy to govern and secure. We should make it simple for all users. So you don't need to go to multiple places and figure out what account we need to go to for what data set. Everything should be available to you at your fingertips. I'm going to bring in Mohan to talk a little bit more about the problems that we're facing and the solutions that we're working towards.
Thank you, Mark. So, Mark, you have taken us through what the ideal data platform should look like. But in reality, if you look at the data platform these days, the data is fragmented all over the place. The big data platform may encompass of multiple accounts where the data is fragmented. The access control and authentications are decentralized. That means in each account, we have to make the similar changes to access the data. The rules for governance are very complex to implement in the data platforms. The user needs to know where the data is exactly to access those data. And data platforms are ever expanding. So you may be inheriting new data platforms. You have to incorporate a lot of changes to bring the data on board. And this leads to a lot of wastage of time and efforts.
That's a great point, Mohan. One of the core tenets of a data platform is to enable the business as quickly as possible by making it easier to onboard data sets without having to manage all those rules for governance and access control, all over the place.
Right. So let's take it a couple of steps and see how we can achieve a better data platform. So let's first, what we can do is we can decentralize the data storage. We can move the compute out. So in this diagram, if you look at, we have multiple compute accounts and data storages are separated out. So the benefit of this is the data is localized, and the data produced by account 1 can be consumed by account 2 and vice versa. So this gives us a lot of flexibility on how we can set up our accounts and how the data should be structured. So if you want, if you are interested more in understanding how the domain-driven architecture is set up, You can visit Caleb's presentation. So sometimes what happens is like we don't have single data accounts. We may end up having multiple data accounts. So the number of connections from computer accounts to data accounts increases exponentially. So it's m into n. So if you have m data accounts and n data accounts, so the connections are multiplication of those. So centralization of data doesn't mean that the data would be in single place. It can reside in multiple accounts. Sometimes those are enforced by the limitations by cloud provider. For example, AWS has some limitations on how many buckets you can create per account. Sometimes you would create intra-company shares, data shares, which you have to consume from computes. So that also would come into picture. In this case, if you look at this, the access controls are still distributed. You have to replicate the access control in all the compute to access the data. This makes security and governance significantly complicated. And also you have to remember which data set resides in which data account. That makes the implementation very complex. To make it simple, what we can do is we can put a shim in between the data and compute and decouple those. So we call that as a federation account. It makes it super simple. So if you bring all the connections can be made, all the connections can be made between the data and compute can go via the federation. So all the roles and policies can be managed within the federation. So if you go with this approach, we can add and remove the data or compute accounts as needed. And there's a lot of scope for expansion in future. This also makes governance and security implementation pretty easy. All we have to worry about is the managing the federation account and scoping over there. Also, it opens up a lot of interesting migration path. Suppose you want to bring some data quickly and you don't have to wait for copying the data into our storage account. You can directly map it to federation and access via the compute.
I think, Mohan, it's also important to touch on. Basically, what we're doing is we're suggesting that we should abstract authentication and access control from both the data storage and the compute. So basically, what that's going to allow us to do is have a really flexible way to bring data sets on really quickly in a very secure and governed way by centralizing the governance and security, as you had mentioned, and being able to move very quickly. Thank you, Mohan. So far, we've talked about federation and a hub and spoke approach for scaling storage in a cloud agnostic way. At Disney, we have an AWS implementation that we had to work through a few problems in order to implement this federated way of accessing data. The first problem that we really had to work through is being able to know where the data exists. How do you know where what account a bucket exists in? The second issue that we needed to work through was an object ownership problem, that essentially anyone that writes to a data account, wherever that IAM role exists, that IAM account is the owner of the data. We'll talk a little bit more through those problems in the next slides. This is the S3 account sharding issue. We'll talk through why it's actually a problem. So in AWS, there is a 1,000 bucket limit per AWS account, which is a hard limit. We already have more than that today. Users don't know which account a bucket exists in. So if you think of the bottom, dotted line area down here as a data lake, it's comprised of many AWS accounts for storage. There's a tight coupling between a bucket and an IAM role that you would need to assume to interact with that storage. An example of that would be a user in a compute account would need to assume IAM role A to write and read from bucket A, but then would need to switch context and assume IAM role B to interact with bucket X. We really want to stay away from tightly coupling storage to access. We need to plan for growth and onboarding new data sets. As we have gone over previously, we want to try to centralize that IAM and authentication into one place to make it simple to maintain. We also want to try to keep it simple for users. Users should not need to know what account to go to for bucket C. They should just know I'm a user and I need to assume this IAM role and I have access to all the data I need. What are some potential solutions to this problem? Well, we could have users all maintain a map of buckets to accounts and IAM roles. That would work for some smaller use cases, like a service deployed into a compute account that may only write to bucket A and bucket Y. It quickly gets out of hand when you talk about a Qubole use case, where an analyst may want to take a look at data sets that span many accounts and many buckets. So we need to plan for storage expansion as well, due to that 1,000 bucket limit, and due to being able to onboard data sets from accounts that are inside and outside of the data platform. Next, we'll talk through the S3 object ownership issue. So essentially, account A on the bottom there writes to general data account 1. Therefore, all objects that are written are owned by account A. Account B and account C cannot read those objects as they are owned by account A. Now, you're probably saying domain account A can assume a role inside of general data account 1 and then write the data, but now we're back to the bucket to account mapping issue that we talked about in the last slide. What are some potential solutions? We could have account A pass an ACL to every object that's written to the data account that specifies to share that data object with account B and account C. That can quickly get out of hand though. What happens when we add account D? Now, every object inside of your data storage account needs to be batch updated to add an ACL to share data with account D. Also, even if we were to go that route, the IAM and access control is now spread out in multiple places, which makes it harder to govern and audit. So what's the solution? Here's what we came up with. Our idea is to add a level of indirection in between our compute accounts and storage accounts. We call this concept federation. A user or service in a compute account assumes a role inside of the federation accounts and has access to multiple data accounts if that's what they're supposed to have access to, without requiring knowledge of what bucket exists inside of what account. In order to make this possible, there was a new feature released by AWS on October 2nd that allows users to force the object ownership to whatever account owns the S3 bucket. We'll talk through a little bit about what that looks like next. How do the innards of this setup actually work? We'll set up our data accounts, number 3 to the right, so that each bucket has a bucket policy that grants access to the federation accounts. The sample over to the left there shows the cross-account trust and also shows a way that we can prevent users from writing data that is not owned by the data account with a conditional check. You can read about this more in the AWS documentation, which we've attached to the appendix. After the bucket policy shares the bucket and the contents of the bucket with the federation account, the federation account can grant access to an IAM role by adding a policy to that role, which grants access to a list of buckets that does not necessarily need to be in the same account. You can specify buckets in data account 1 and data account 2 without specifying the location of those buckets. This is possible because of the global namespace for S3. The new magic feature from AWS is called Bucket Owner Preferred. And basically what this does is forces anyone who writes to the data accounts to relinquish ownership on the objects that they write to the data accounts themselves. Therefore, you can read and write to that bucket from different accounts without having to have an IAM role that exists inside of the data account. Let's walk through this again end to end. A bucket policy is set up in data account 1 to share access to the federation account. The federation account then creates an IAM role, which may have a bucket from data account 1 and data account 2 that a user in a compute account, and the compute accounts number 1 to the right, would assume and be able to access the data seamlessly across accounts. This is a pretty powerful concept. This allows us to centralize governance and security to focus on the federation accounts, number 2 to the right. So, how does this work with Qubole? Well, the Qubole control plane, number 1 to the right, spins up a cluster inside of a Disney-owned compute account. That compute account cluster will assume a role inside of the federation account and be able to access data regardless of the location of that data as shared via bucket policy to the federation accounts. What are the limits with this federation architecture? Well, in AWS, there are limitations not only around buckets per account of 1,000, there are also limits around the number of IAM roles that you can have per account. That limit is 5,000. That's why you see 2 federation accounts. Really shouldn't affect users assuming a role, as a user is really only concerned with the role that they assume, regardless of the location of that role. Order does matter when creating IAM roles. So when creating a new bucket, you have to create the bucket and add the bucket policy previous to creating the IAM role. Otherwise, you'll get an error. Not really a problem and can be solved via automation. This architecture does add more complexity by adding additional federation accounts. However, that complexity is offset by the simplicity that is, given to the security and governance aspects of the data platform. The bucket preferred user feature from AWS is not available in CloudFormation yet. So as a temporary workaround, we're going to have to enable that feature inside of the console. That feature will be added soon. Users will need to pass an ACL along with every object that they write through the federation accounts that signals to AWS to pass on the full bucket control of the object to the data account. One last limitation would be that users in the compute accounts that are normally familiar with using the AWS CLI to list the S3 buckets that they have access to no longer can do so. This stresses the importance of a metadata management system inside of the data platform. We won't cover that here. Okay, at this time, I'm going to bring in Mohan to talk through the live demo that shows Federation in action. Mohan?
Thank you, Mark. So today we have set up a small demo. So let's talk about the setup first. So number one, here we have QVol control plane, which spins up a QVol cluster within our AWS account. So we call it as QVol account or a compute account, domain one. And it's going to access data written in data account one, and it will read it from account two. And it will do via the federation. So we are basically accessing multiple data accounts, and we will go through the federation. So before that, we have to do a couple of settings in QVol. So if you go to QVol advanced settings, there is a Hadoop cluster settings. In that, you have to enable bucket owner full control. So this allows basically whatever data written by the federation account to be owned by the data account. Also, since we will be assuming another role, so we have to add this statement, secondary role to be assumed, and it has to be the federated role. And since the dev lock is in the existing QVol account, we have to add the role mapping for the dev lock. So let me pull in the console for a live demo. Yeah, so we have a small setup. So if you look at, this is the QVol account run by QVol control plane in our compute domain. And the setup is pretty simple. So from this QVol control, I will assume a role. And first I will write some data into data account one. So this is the bucket. There is nothing in there. And then I have some data in my another account, which I'm going to read from that. So this will basically explain that I can work with multiple data accounts via the federation. So the first paragraph is basically I'm constructing a small data set, and I'm writing it to the data account one. So let me execute that first. So I'll go to data account one, refresh my S3 bucket. So here's the data written by the QVol. So the second paragraph is basically I'm reading the data from another bucket, which is in account 4. And I'm just printing it. So this demonstrates the power of the federation. So via the federation, I can read and write from multiple data accounts.
Yeah, I think this is a really powerful concept that allows us to obfuscate where the data is actually stored from the user. That allows you to, really move quickly. If you were asked to bring on a data set into your data lake, it doesn't necessarily mean a data migration project anymore, as security and governance have the controls that they need to have to control access to the data without actually having the data exist in one of your accounts. All right, cool. So we've walked you through the federation architecture and showed you a live demo to show the power of the federated hub and spoke model approach to scaling data storage. So let's just reiterate some of the potential benefits of setting things up with this layout. It's really important to stress that the data locale is transparent to the user. They don't necessarily need to know where the bucket exists. They don't need to know whether it's inside of your platform or external to your platform. It's very easy to flip a light switch and enable the business by bringing in data sets faster than you ever have before. Governance and security can now focus inside of the federation accounts for audit and, different monitoring abilities focused inside of the federation account rather than trying to focus them in a distributed manner. There are also more knobs and levers that governance and security can, toggle, because now you have a bucket policy in which you can restrict, certain functionality from the federation account. For instance, if you've never wanted anyone to be able to delete a bucket, you could add that right into your bucket policy. So there would be no chance for misconfiguration inside of the federation account. It's easy and fast to onboard new data sources. You can have data migration projects that can be done in a period of days rather than months and years. There's an extra layer of control. It's also really nice to have the ability to have audit logs and traceability in one place, the federation accounts. That's the end of our presentation, and we really appreciate the time that you've spent with us today, and thank you for coming.